In this video, we are going to talk about discrete probability density functions. And you're not really going to need any fancy functions on your calculator. Any calculator will work. We're just, we might do some fraction addition kind of thing, but we're not going to do anything fancy. So luckily, I won't be switching my screen back and forth. Okay, so here we have, oops, let me get the right one to start where I can write on it. I actually have this file open up 3 different times on my computer. So wanted to make sure it was the one I could write on. Okay, so here we have a 4.1a, discrete probability density functions, and that describes the probability that a discrete random variable will take on a particular value. And so there's 2 things to take away from probability. They are listed right here. We have talked about them before, but they are worth repeating, because they will not only come up again and again in this chapter, which is typically about probability, but they surprisingly appear a lot in the future, even when we move away from probability. So first things first, each individual probability is either greater than or equal to 0 or less than or equal to 1. It's got to be in between 0 and 1. It could be 0, it could be 1, or anything in between there. It cannot be negative, and it cannot be greater than 1, because that would be like saying the probability of something is over 100%, and we can't have that. The second rule is that the sum of all probabilities is 1. And so I'm highlighting this symbolic notation because in future videos, that's how I like to write it out. But you can see right above both of those symbols at the bullet points, it's written out in words as well. So make sure you can get the hang of it. Okay, so first question, we have a table right here. This table below gives a probability density function for some discrete random variable x. What is the probability that x is 1? And so you can see these tables written out sideways, horizontally like we have here, or you'll also see them written vertically up and down. But you'll notice that the row or column, whatever is relevant in that particular problem, one will be headed with x, and the other one will be headed with the probability of x. So in this example, it says, what's the probability that x is 1? So we go to where x is 1, and we're talking about this x value right here. And then the probability that x is 1 is given in the row that says p of x, the probability of x. So we could write out this whole question and answer in simple notation. And I want to keep re-emphasizing the symbolic notation because the homework will bounce back and forth between the symbols and the words. So this question was given in words, but another way you could say that is, what's the probability that x is 1? Probability of getting a 1. And we have seen from the table that that is 1/4 or 0.25. Okay, next up, it says a fair dice is rolled, and the sum of their faces is recorded. The probabilities of each sum are recorded in the table below. Answer the questions that follow. So before we get into this question, I want to really make sure everyone understands what this table is saying, because we're going to use this table in this section, and I think it comes up in the next section as well. And so we have, I'm going to try to draw, but it's not going to be 3D, I can tell you that. So we have, here's a die. Okay, it's not the worst thing I've ever drawn. And it says we have a pair, so there's 2. And so you roll the dice, we roll both of them, and the smallest you can get on each one is 1. So if you roll a 1 and a 1, that adds up to 2. And this keeps on going. I could have rolled a 1 and a 2. Oopsies, where did my other dot go? 1 and a 2. Okay, it keeps erasing for some reason. There we go. A 1 and a 2, that adds up to 3. But I also could have rolled a 2 and a 1. That also adds up to 3. So there's different ways to get the different numbers. In fact, if we are adding up to 6, for example, we could have 1 and 5, we could have 2 and 4, or we could have 3 and 3, or we could have 4 and 2, or we could have 5 and 1. So there's all different ways to roll 2 dice to get 6. But there's only one way to roll 2 dice and get 2, because 1 and 1 is the only way with dice that you can add up to 2. Okay, not what this question is being asked, but again, we are going to use this table multiple times, so I want to make sure everyone's familiar with it. Okay, so it says, what is the probability that the sum of the faces is 4? So again, in symbolic notation, that would be the probability of rolling a 4. And we just look at our table. We see here's 4. Okay, so that probability is 1/12. Next, which sum is most likely and which sum is least likely? Well, you might have some general world knowledge on the topic. You might just know stuff about dice. You might know nothing, and these fractions are making things even more confusing. So when I said we're going to do some basics, basic fraction kind of stuff on the calculator, I'm not going to pull up the calculator because everyone can do this. But for example, if I want to know what 1/36 is, I would just hit 1 divided by 36, and then I could just get it as a decimal, 0.02. We'll just round that to an 8 because there's a bunch of 7s. But maybe, some of these you might know which is bigger and which is smaller, especially where all the numerators are 1. When all the numerators are 1, then the smaller denominator makes the bigger number. But 5/36, that's kind of a random one in there. So I can again go to my calculator, do 5 divided by 36, and I can get 0.139. 1/6 is 0.167. So again, if you're not sure which way these fractions are going, find decimal values for them. But what you can see is that it kind of goes in a pattern. So we have 1/36 on both ends, and then we have 1/18, and you can see that pattern going into the middle of 1/6. So the most likely, the biggest decimal, these numbers are starting off small and they're increasing. The most likely would be 7, because the probability of 7 is the biggest. I'm just going to say biggest probability. Which sum is least likely? Well, I have a tie. The ones that I highlighted in pink are both 1/36, and 1/36 is the smallest fraction. So 2 or 12 is the least likely. They're tied for the smallest probability. When I said you might just have general world knowledge on the topic, it's because we talked about 2. The only way to get a 2 is a 1 and a 1. There's only one way to get a 2. That's very small probability. Similarly, with the 12, you can get a 6 and a 6, and that's it. That's the only way to get 12 with a standard fair 6-sided die. So those two are going to have the smallest probabilities because there's just not very many ways to make them. But 7 has 1 and 6. I'm already forgetting how to add a 7. 2 and 5, 3 and 4, 4 and 3, 5 and 2, 6 and 1. All different kinds of ways, depending on which dice you're rolling. And there's just a lot more ways to add to 7. 7 is the most likely, has the biggest probability. Okay, enough about that. We will come back and talk more about dice in the future. So we've read probability tables, basic discrete probability functions, and now we have one where there's something missing. And so we are missing a value here, and we're trying to figure out what that is. Now we're going to use the fact, there's 2 things here. One, the one that's going to be most relevant is that the sum of all the probabilities has to equal 1. That will be the easiest way to get to this answer. And we can double check our answer by noting that each individual probability has to be between 0 and 1. So if I end up getting a negative, or if I end up getting a number bigger than 1, I'll know I did something wrong. But for me, the easiest way to do this, since we just have one missing number, is to add up all those numbers on my calculator. So again, we're just doing some basic addition, nothing calculator fancy. And I add those up and I get 0.98. And I know the whole thing has to equal 1. So a quick way to think about this, if I know I have $1, here's 98 cents. How much is left? Well, there's 2 cents left, 0.02. 98 cents plus 2 cents equals $1. It's not always quick. It's not always money. It's not always something you can do in your head. So the way we figure out this is we say the whole thing is 1, and then we subtract the 0.98 that we calculated above. So that's how you would get the 0.02 if it was something that you weren't able to do in your head. And again, a lot of times you can't do them in your head because they're just weirder numbers, like $1 minus 36 cents. That's just not as common as the 2 cents. Okay, moving on. Which of the following tables show a valid probability density function? Okay, I'm going to say it again. I'll say every problem if I need to, because these are the 2 important things for chapter 4 that will keep on keeping on. We will hear about these throughout the rest of the course. So the sum of all the probabilities equals 1, and each individual probability needs to be between 0 and 1. Okay, so right off the bat, there's a couple that I can throw out without really checking anything. So for example, down here on the 6th one, I have a negative. That's no good. We can't have negatives, and we can't have anything bigger than 1. So this is not a probability, valid probability density function, because there's a negative. I don't care what they add up to. They could add up to 1 for all I care. Both things have to be true. So if I notice that one of them is not true, I don't even have to check the other one. It's automatically not true. All right, another one that you might be able to quickly check. See, like this one over here, that's too much carrying. I'm not going to quickly, I'll do that on my calculator. And then these other 3, there's too much fractions. I'm not going to do that in my head. I'm going to use a calculator. But this middle one right here, I noticed the 0.7 and the 0.5. Well, 7 plus 5 is 12. So this is too big. So this one is not, this one is not, because the sum of everything did not equal 1. It could be bigger than 1 or less than 1 to fail this test. This one failed because it was bigger than 1. And you could even put that if you would rather. You could say it's not because when I added them up, it was bigger than 1 and it was supposed to be equal to 1. All right, so the other ones, we can just do a quick check on our calculator. It doesn't matter how you enter in the fractions, if you use the fraction button or if you use the division key, as long as you're just typing each number in and then you hit plus, or 1/4 plus 3/8 plus 3/8, that equals 1. Everything there is in between 0 and 1, so that's good to go. Going across the top, I'm going to go right here next. I have the decimal, so I just hit 0.18, that's 0.76, that's 0.06, and that works. Again, all the rest of the choices, other than that highlighted one, all the rest of them, they didn't have any negatives. They didn't have anything greater than 1. So all the others passed the initial test. And now I'm just doing the second test, which is to add up to equal to 1. I like to do the easy one first. And looking for a negative to me is the easier one. But this one isn't too terrible. I'm just going to, whoops, I'll do it right this time. 1/8 plus 1/8 plus 3/4. And if you're good with fractions, you might get this pretty quick. But that does equal 1. Perfect. And last but not least, 1/10 plus 1/5 plus 3/5. And now I see that it equals 0.9. So I'm going to say not, because the sum of the probabilities was less than 1. So it doesn't matter if it's less than or greater than 1, those are both out. If there's a negative or if there's a number greater than 1, that would be out too. So just to point out, this last one that I highlighted pink, this guy would be acceptable because it equals 1. It just can't be, it can be less than or equal to 1. It just can't be greater than 1. So that yellow highlighted part, that's allowed, but it doesn't matter because the pink part already made it fail. Okay, next up, here we have some various x's given, and this time we have the tables listed. Well, we did last time too, I just forgot to mention it. We have the tables listed vertically, so they're going down, but again, you can see the name of them. At the top, we have our x, and then we have our p of x, our probability. So this is, what's the probability of that x is 1, 2, or 4? So I could just write that out. Probability of 1 plus probability of 2 plus the probability of 4. Okay, cool. So I have the probability of 1. I'm just going to highlight them first. We have the probability of 1. Ooh, that was not my highlighter, was it? Try that again. Probability of 1 is right here. Probability of 2 is right here. And the probability of 4. So I'm going to come down here and write those in 1/20th. I almost wrote 1/20th plus 7/20 plus 1/10. I'm not even going to mess with common denominators. Again, different levels of expertise. If you are good, some people are faster to do common denominators. Other people are faster to type it in their calculator, whatever works for you. But I'm getting that the reduced answer here is 1/2. So if you found common denominators, you would have gotten 10/20, but we want to list the answer in its final reduced form. So we have 1/2. Okay, last one. Hopefully you like this section. This section isn't too terrible. The last one, it says the table below shows the probability density function for a discrete random variable x. The number of coffee cups an employee brews per day on an office coffee machine. Okay, that's what x is talking about. 0 cups of coffee, 1 cup of coffee, 2, and so forth over here. And then we have the probability of that many cups of coffee over in the second column. So now we have chunks here. This one says, what's the probability that x is less than 3? Now, we want strictly less than. We don't want to include 3 because it just says less than 3. We can't include actual 3 here. So that would be everything from, let me get a different color here. That'd be everything from 0, 1, and 2. This right here is where x is less than 3. So this would be 1/8 plus 3/16 plus 3/8. I'm just going to take those 3 probabilities in the blue box and then put them in my calculator. 1/8 plus 3/16 plus 3/8 is, and then it gave me my answer as a decimal. Typically, if the question is asked as a fraction, it wants it answered as a fraction. So if you have a calculator like mine, you just hit the wiggle button right above the equal sign. I would show you, but I actually forgot to bring my calculator with me when I was doing this. So let me just tell you that the answer is 11/16. And please email me if you are not sure how to go from that 0.6875, which is what the calculator gave me, to 11/16. And I can show you on your calculator how to switch from fractions to decimals. We have talked about it, but it was like a little while ago. But again, if you have a calculator like mine, it's right above the equal sign. There's a button with 2 little arrows like that. That's how you switch. Okay, next up, what is the probability that x is greater than 3? So again, we're not including 3. In fact, we're just looking at greater than 3. So that would only include the 4 and the 5. Oops, I did my sign backwards, but greater than, the alligator's eating the 3. Let me erase that. So I'm going to get 1/8 plus 1/8, and that adds up to 1/4. Throw it in your calculator, you'll get 1/4. Again, be mindful of how the problem is asked. That's typically how they want it answered, meaning if you have a fraction question, they're looking for a fraction answer, and a decimal question will lead to a decimal answer. Sometimes they don't care, but a lot of times they'll tell you which is which. Okay, last but not least, what is the probability that x is equal to 3? So you would see that written as either p of 3, or I'm just going to write it this way this time so it matches the other notation. You might see sometimes probability that x is equal to 3. That's the same as that notation. Those are the same. It kind of just depends on the problem. I don't care which one you write, but I want you to be familiar with both notations in case it's written like that in the homework. Okay, so last but not least, x is equal to 3 is just the 3. So that would just be 1/16. All right, the next one will be the next video. So that is it. Please let me know if you have any questions, and I'll see you in the next video. Bye.